Hi everyone, this video is going to be about the gas laws. So in your packet of fun, you can be following along on page 5. And if you'd like, you can also have the notes open as well. So the first thing I'd like to talk about are the different measurable properties of gases, and a lot of times you will hear me refer to them as variables. So in our gas laws, scientists have compared what happens to pressure if temperature is adjusted, what happens to volume if temperature is adjusted, what happens to pressure if volume is adjusted, and all that stuff. So the 4 variables that we're going to be talking about is pressure, and it's going to be represented with a P, temperature with a T, volume with a V, and the number of moles is going to be represented with an N. A couple things to remember. Don't forget that pressure is how often the particles hit the walls of the container. So if the particles hit the walls of the container more often, then there's a higher pressure. If it's less often, then there's a lower pressure. For temperature, it does have to be in Kelvin for our gas law calculations. And remember that Kelvin is equal to your degrees Celsius plus 273. That will equal your temperature in Kelvin. So keep that in mind when we get to the calculations portion of the gas laws. So the first law, I'm going to switch over to the packet of fun, actually completely. And what we can fill in up here are the measurable properties. So we have, temperature, which needs to be in Kelvin. We have volume. There was number of moles represented by an N. And then the last one was pressure, which is represented by a P. So that's what you can put up there. Now, the first law that we're going to look at or talk about is Boyle's law. And Boyle studied the relationship between volume and pressure. So volume and pressure. So if we take a look at this little picture here, we see a particular volume of gas, and these gas particles are moving around in this container, okay, exerting pressure on the walls every time they hit the walls. Now, if we remove the amount of space that the gas has to move and we squish it into a smaller area, I want you to think about drawing air into a syringe, covering the end, and then pushing the plunger inward. It's going to be harder to push down. What's happening is that as you decrease the volume, the pressure within the container is increasing. And this is the relationship between volume and pressure. So I'd like you guys to write that down. As you decrease the volume, there's going to be an increased pressure. Now, with that being said, if you increase volume, there's a decrease in pressure. Now, if you remember back to the virtual labs that you guys did, and I'll show you this visual as well, I'm going to decrease the size of this container, and I want you to watch what happens at that pressure gauge. Right now, it's at 5.8 atmospheres. And if I decrease the amount of space that this gas has to move, then that pressure goes up. So you can see that the gas is hitting the walls of the container more often, so there's a higher pressure. If we make this container larger, we see that pressure go down to 3.9 atmospheres. The gas is still flowing at the same speed. The temperature has not changed, but because of the greater amount of space the gas has to move, it doesn't hit the walls of the container as often, and therefore the pressure is lower. So because as one increases, the other decreases, this is called an inversely proportional, or an inverse relationship between these two variables. So we have an inversely proportional, or inverse relationship would be fine as well. The next gas law that we're going to talk about is Charles' law. And Charles studied the relationship between temperature and volume. So he studied what happens to the size of something if we heat it up. What happens to the size of a gas if we cool it off. So we're going to take a look at this picture here. And you can see that the balloon in the ice water is a lot more deflated. It appears as it's deflated. But what happened was, as the temperature of the gas within the balloon, as the temperature decreased, the speed of the particles, it was slowing down. So the particles aren't exerting pressure on the walls of the balloon as often, and the gas contracts, and the volume gets smaller because those particles are moving slower. If you take a look at the boiling water one, as that balloon is being heated up, the gas within it, those gas particles are moving a lot faster and they're taking up a lot more space, so the volume increases. So over here, the relationship is as we increase the temperature of a gas, there's an increase in its volume. If you decrease the temperature of a gas, its volume will also decrease. This one is a direct relationship or directly proportional. And that's Charles' law. Gay-Lussac's law is next. And he studied the relationship between temperature and pressure. And we'll take a look at this image on your page. So if you take a look at the left-hand side, there are particles moving around in this container. And at the bottom, it does say cool gas there at the bottom. Now, if the gas is being cooled, that means that the temperature is going down. What happens is that those particles are moving a lot slower. Okay, they're still moving because they're gases. They're still moving, but they're moving a lot slower. So it's hitting the walls of the container a lot less. So because the gas has been cooled, the particles are moving slower, and therefore the pressure goes down because they're not hitting the walls of the container as often. So we can write, as there's a decrease in temperature, that equals a decrease in pressure. If we take a look at this next picture, it represents a hot gas, and you can see that there are a lot more arrows on this picture. So a hot gas means that those particles are moving a lot faster. They're speeding up. So if they're moving faster, it means that they're hitting the walls of the container a lot faster and a lot more often. So the pressure is going to increase with that increase in temperature. So an increase in temperature equals an increase in pressure. And again, it's because those particles are hitting the walls of the container more often. This is a direct relationship or directly proportional. Now, the very last one that we'll do is Avogadro's law. And if you remember hearing that name, Avogadro studied or came up with the number for a mole, 6.022 times 10 to the 23rd. And his has to do with number of moles and volume. And again, this is of a gas. Okay. So he studied how the number of moles affects the volume of something. And I think that the easiest thing to think about is blowing up a balloon. Because when you blow up a balloon, you're adding more and more molecules to the balloon. So what is happening to the size of the balloon as you add moles to it? Well, if you blow up a balloon a little bit, it's a particular size. So we have this particular size here. If we put more air into it or increase the number of moles that we put into the balloon, then the size gets bigger. This is probably the easiest gas law because it's the one that makes the most sense. The more you have, the bigger it is. That's basically what this is saying. So the relationship is, if there's an increase in the number of moles, that equals an increase in volume. And if there's a decrease in the number of moles, then the volume is lower. This is a direct relationship as well.